Welcome to The Explainer. I am absolutely thrilled to have you here today because we are diving into something that is literally a game changer for your exams. Our core mission today is straightforward but absolutely vital: mastering the Cambridge IGCSE Physics 0625 exam strategy. But listen, we are not just going to sit here and memorize a bunch of dry, boring facts. No way! We are going to move far beyond raw memorization and look at the key concept structure and the first principles explanation for measuring length and time. I want you to think of this like preparing for a high-stakes space mission. In a space launch, there is absolutely zero margin for error. Every single calculation, every measurement of distance, every fraction of a second must be completely perfect for launch, or the whole thing falls apart. That is the exact mindset you need for this exam. If you want to actually understand the physics, stop guessing, and secure those absolute top marks, you are in exactly the right place. Grab your notes, get focused, and let's launch into this.
Okay, let's dive right into this. Any truly strong physics lesson and any top-tier exam strategy needs to start with a crucial foundational question to anchor your thinking. So ask yourself right now, what physical effect, measurement, or prediction actually depends on understanding how to measure length and time? We have to ask this question up front to make the idea feel necessary, not just like some decorative math problem you're forced to do. Think about our space mission analogy. Before we even touch the formal mathematical language or write down a single equation, we need to understand exactly why we are measuring these things in the real world. Does a fraction of a second change the trajectory? Does a millimeter of length alter the entire physical effect? By answering these fundamental questions first, you make yourself far, far less dependent on memorized wording. You become so much more capable of reasoning your way through those incredibly tricky, unfamiliar exam questions that always seem to pop up and panic students.
All right, here is our incredibly focused roadmap for today's explainer. First, the crucial question. Second, the four-step framework. Third, real-world applications. Fourth, beating exam traps. And finally, number 5, quick recall mastery.
Let's kick things off with Section 1, the crucial physics question, moving from everyday language to physics vocabulary.
You know, easing into the formal, highly specific language of physics is incredibly important, so we aren't just blindly reciting words we don't actually understand. This sequence brilliantly illustrates exactly how we make that transition successfully. Using a concept-first teaching approach, you never start with the intimidating equation. Instead, you begin with a very concrete, everyday example, something you can literally picture in your head or hold in your hand. Once that real-world concept makes perfect sense to you, only then do you introduce one symbolic relationship or definition. But again, you only do this when you are completely ready for it. Finally, you bring it all back to a fully worked explanation to lock it in. This gradual step-by-step progression builds massive, massive confidence. It gives you the power to actually reason through the science rather than just hoping you remember a formula. Before we continue on to the framework that will transform your grades, subscribe to our YouTube channel Ace the Exams, at acetheexams_IGSC to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving right along to Section 2, the four-step framework, building the core explanation.
Listen closely because this framework is the absolute gateway to solving literally any IGCSE physics problem they could possibly throw at you. Let's methodically pace through these 4 linked steps. Step 1 is to simply identify the quantity or the phenomenon. What exactly are we looking at? Is it a pendulum? A distance track? Step 2, state the relationship involved. What connects the variables? Step 3, explain the underlying physics. Now, this is the magic step. This is where you actually show your reasoning and prove to the examiner that you know what's happening behind the scenes. And finally, step 4, connect it all to an observation, an experiment, or a real-world device. The absolute best physics answers in your exams, the ones that get perfect scores, will always, always demonstrate both as deep theoretical understanding and a crystal clear practical application. If you skip a step, you leave marks on the table. I absolutely love this quote from our source material. Insist on cause and effect rather than isolated facts. I really want you to let that sink in for a moment. Whether you are dealing with magnetic fields, gravitational forces, electrical circuits, or in today's specific case, measuring length and time, understanding the physical cause and effect chain is what actually scores you the big points. Memorizing an isolated fact like a robot might accidentally get you 1 lucky mark, but clearly explaining the cause and effect shows true, undeniable mastery. It tells the examiner, I don't just know what happened, I know exactly why it happened and what it will cause to happen next. It's that chain reaction of logic that turns a B-grade answer into an A-star answer.
All right, Section 3, connecting to the real world, physics outside the classroom.
I want you to think for a second with real, energetic curiosity.
Where does measuring length and time actually matter out there in the wild? Going back to our space mission analogy, these measurements are quite literally the backbone of modern engineering and transport. They are absolutely critical for safety systems. Think about the exact hyper-precise microsecond timing required for the airbags in a car to deploy during a crash. If that specific time measurement is off by just a tiny fraction of a millisecond, a life-saving system instantly becomes a massive hazard. These same fundamental measurements regulate our massive energy systems, they make complex communications and medical technology possible, and they even allow us to map the furthest stars in astronomy. These aren't just dry, boring textbook concepts meant to torture you. They predict, safeguard, and improve real outcomes across massive, multi-billion-dollar global industries with zero margin for error.
So the absolutely crucial takeaway here is this. When you are sitting in that exam hall, I challenge you to always ground your theoretical answers. Always name at least one real-world situation where the concept you are writing about actually matters, and completely justify why the physics applies there. Linking the classroom theory to a practical, tangible example immediately shows the examiner that you truly grasp the subject on a deeper level. It proves you aren't just a memorization machine. Stop scrolling, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 great boundaries. Join them right now by subscribing to at Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Now let's get into Section 4, Avoiding Common Exam Traps, Safeguarding Your Marks.
Okay, it's time for a bit of insider knowledge to help you avoid the brutal pitfalls that cost so many students crucial marks every single year. Let's imagine 2 hypothetical students taking this exam. We'll call them Alex and Sam. Alex overloads his brain with raw physics facts, but does zero analysis. When faced with a question, he falls into the ultimate exam trap, writing down naked formulas. He just throws a mathematical equation onto the page, completely out of context, and hopes for the best. No explanation, no breakdown, just naked math. Please, whatever you do, don't be like Alex. On the other side, we have Sam. Sam rushes through the paper, completely missing the specific command words the examiner used, and loses marks because he didn't actually answer what was asked. Instead of guessing, you need to use the foolproof DR-HIA method. That stands for definition, relationship, explanation, application. First, to clearly define the concept. Second, you state the relationship. Third, you actually explain the physics involved. And fourth, you apply it. This highly structured method acts as a shield, safeguarding every single mark available to you.
Let's break down those specific traps a bit more clearly, so you know exactly what to watch out for. Here are 3 incredibly common weaknesses you must avoid at all costs. First, writing a perfectly correct formula but completely failing to explain the variables. If you write V equals D over T, you absolutely need to state what V, D, and T actually represent. Don't assume the examiner will just give it to you. Second, quoting a scientific process without actually linking it to a real physical effect. And third, giving a practical example without showing exactly why it logically follows from the physics you just explained. Remember Alex and Sam? They lose marks here because they don't connect the dots. You counter every single one of these errors by keeping your logical reasoning tightly, forcefully connected to actual physical effects. Never, ever leave the examiner guessing what you mean. Spell it out clearly.
Almost at the finish line. Section 5, Quick Recall Mastery Checklist. Let's test your exam readiness.
Let's bring the energy right back up for our final active learning checklist. This is the tool that guarantees your topic knowledge is completely secure and bulletproof for those rapid-fire short answer questions. I invite you right now, wherever you are, to pause and mentally test yourself against these 4 specific prompts. Number 1, what is the core idea of the concept? Number 2, what actually changes physically in the system? Number 3, what specific quantity or graph visually shows this change? And if it is a graph, what does the slope or the area underneath it actually mean? And finally, number 4, where is this concept used in the real world? If you can confidently answer these 4 prompts aloud without checking your notes, you have successfully bridged the gap from passive listening to active top-tier exam mastery. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
I want to wrap up today's explainer and leave you with this final, highly provocative thought. If your physics answer relies purely on memorized wording rather than a deep understanding of cause and effect, are you really explaining the science, or are you just reciting it like a parrot? Really think about that as you continue your revision. Strive for genuine understanding, forcefully apply that first principles reasoning to all your future physics challenges, and you will absolutely conquer that 0625 exam with flying colors. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the exams, your Cambridge success starts here. Thank you so much for joining me, and keep asking why.